So this is the last two questions on the 2017 AP Chemistry Free Response I'm going to go over. The first question is clearly a calorimetry question. Remember, what's critical here is going to be the relationship between Q and delta H. They are not the same thing. If you take delta H is really equal to the amount of energy released per mole, okay, of something. That's a critical concept they want you to understand. All right. It could also be delta H per 2 moles or 3 moles if that's what the reaction is. Depends on how the question is worded. All right, so let's look at this question. We've got some alcohol here. They're telling you it's an alcohol, so you don't need to know that fact, and it is being combusted. The mass of the alcohol combusted is determined because they weighed it before and after. So the way I look at this question, they're telling me that they know how much alcohol was burned. Look at the grams right there. I bet you I'm going to have to convert that to moles. Now, they're not measuring the temperature of the alcohol, are they? This is a heat transfer situation. The heat is being transferred from the alcohol that's combusting to the water. The water is like a calorimeter. Its temperature is being measured, its temperature change is being measured, and they're giving you the following things. They're giving you the mass of the water, they're giving you the delta T of the water, and they're giving the specific heat of the water, all with 3 sig figs. Now, let's go down to the questions. Okay? It says calculate the magnitude of heat energy absorbed by the water. This is an MC delta T thing. So you can just do MC delta T with this thing, and you'll get the amount of energy absorbed by the water. The amount of energy that's absorbed by the water, okay, is going to be given to you in joules, because this is joules right here. They want the answer in kilojoules, which is what delta H's are usually given in. So make sure you can do the conversion, because when you get Q in this particular case, your Q is going to be given in joules, and you need to convert that into kilojoules. It's going to have 3 sig figs, because everything else has 3 sig figs. Even when you subtract 51.1 and 22.0, you end up with 3 sig figs. All right, then it says, based on the experimental data, if 1 mole of CH3 is combusted, how much heat is released? So now they're asking you how much energy would be released if you burnt a mole of the substance, right? Oh, look, they're giving you the grams. Now, be careful here. This only has 2 significant figures. So they're looking at sig figs on this. They wanted you to round the next answer at only 2 sig figs, because that leading 0 is not significant. Only trailers, when decimals are present, are significant, and ones that are in between. So you have the amount of energy released already. You already have Q, and they want you to put the number of moles underneath it. Well, you have the amount of energy released when you burnt this much. So whatever you got in kilojoules, okay, it's per 0.55 grams. All you want to do is convert that to kilojoules per mole. So convert this to moles and divide through. The third part of the question says, well, okay, so we are burning alcohol. Now, what if we did the experiment again, but we did it with alcohol that was contaminated with water? Would the final temperature of the water be greater than, less than, or equal? And you must justify your answer. There's lots of ways of doing this. You can justify it verbally or mathematically, okay? But you have to explain the assumptions you're making. And I'm not going to tell you the answer, but I'm going to kind of lead you a little to it. There's the question you need to really ask yourself. If the mass of the thing went down by 0.55 grams, and it was impure because it was contaminated with water, did you burn 0.55 grams of alcohol? Did you burn more than that, or did you actually burn less than that? Which one is it? Because if you burnt less of it, right, then less energy is released. If you burnt more of it, then more energy is released. You follow? And that's going to affect how much the temperature goes up by, how much energy is released. More energy is released, temperature goes up more. Less energy released, temperature goes up less. And you could actually show math here if you want to justify. You say, well, what if I only burnt 0.50 grams of alcohol, right? How much energy would be released? You could actually show it quantitatively if you so desired and had the time. Okay, this is a KSP problem. I'm guessing a lot of you guys have forgotten it, and it's a mixture of 2 different things. You got to figure, when this AP exam happened, kids were burnt out. They're on the last 2 AP exams, and they throw this at them like, oh my God, right? So you either know how to do KSPs or you don't. Quick reminders for KSPs. There's no denominators, because the thing on the left is always a solid. You have ones that are X and X. You have X and 2X, X and 3X. Right? Like aluminum chlorides, for every 1 aluminum, you're going to get 3 chlorides, etc. Right? So just my quick intro to reminder of what this looks like. And X is going to be molar solubility, right? So if you figure out what X is, then you know how many moles of this there are per liter of solution. If you figure out X for this one over here, then you're figuring out how many moles per liter you have of this. If you figure out X for this one, you're figuring out how many moles per liter you have for that. And if they give you a volume, you can get the moles because you know the molarity formula. Here we go. It says, the first thing says the KSP is this value here. So they're giving you KSP, and they say calculate the number of grams that could dissolve in 100 milliliters of water. And they even give you the GFM to make your life easier, okay? And they're giving you the temperature. Now remember, temperatures are always going to be given in any equilibrium problems because the values for the equilibrium expressions change with changes in temperature, right? Right. Remember, if the four directions endothermic, it's going to favor that reaction. If you increase temperature, the value for K will get larger. Okay. If the flow reaction is exothermic, then it favors the reverse temp way when the temperature goes up and K will get smaller. So K values change with changing temperatures. It doesn't mean the temperature is actually any part of the math, right? It's just telling you that this value here is only at 25 degrees Celsius, right? And then it says calculate the number of grams of this dissolved. So I don't want to tell you too much, but you've kind of got a similar one right here. Solve for X. X will be a molarity. Molarity is equal to the number of moles over the volume in liters. If you have the moles, you get the GFN, you should be able to get the grams. 3 steps of math, essentially. For letter B, it's asking about last energy. It gives you the last energies, and it tells you the first one has a stronger, higher last energy than the second one. Sorry. Well, there's 2 variables here, all right? The first variable, okay, is the charge difference. The second variable is the size of the ions. I don't want to get into this and explain it, right? But you should look at the charges on the ions, see if they're different. If they're the same, that's not the variable they're interested in. If that's not the case, then go to the size. That's the secondary variable we look at and compare sizes. I would suggest if size is important in terms of this thing, you might want to avail yourself of the periodic table to determine why the and again, if you're justifying this, write down the formula for lattice energy, right? And show how this number would be different and therefore that number would be different. You can always justify these things by showing math. And what I mean is, like, you don't have to use real numbers. You can use like fake numbers. You say, well, look, you know, if this is +1 on the top and +1 on the bottom, and the other one's both +1 and +1, if the bottom number was, 200 picometers, then in the first case, in the second case, the bottom number was like 600 picometers, clearly the last energy here would be greater or smaller, right? So you can use fake numbers to justify things to show you understand the concept. It's like I do when I'm teaching. Same idea, except now you're teaching to a reader.